Hello, welcome to our online class, and in this self-study lesson today we shall look at heat transfer, which is the process or how heat travels through the states of matter, which include solids, liquids, gases, and then vacuum. Heat normally transfer or is transferred in solids by conduction, and then in liquids by convection, and then in gases by convection also, just like in liquids. And then lastly, in the vacuum space, the heat is transferred or travels by radiation. A vacuum is a space without molecules. It's an empty space. Molecules act as a medium of heat transfer, and heat transfer fastest in gases. Why? Because the molecules in gaseous state move freely than in other state of matter. Heat travels slowest, or heat is transferred slowest in solids. Why? Because the molecules do not move freely in a solid state. An illustration of heat transfer in solids: we see a candle put at one point of the bar with three test tubes placed on top of the bar. We can see that this test tube next to the candle or next to the heat source has a higher temperature as compared to this, and this test tube, the test tube which is the farthest point compared to the heat source, has a low temperature. That means that it illustrates the transfer of heat in solids. The description of the diagram is this, so you can pause the video and try to read through and understand the transfer of heat by conduction in solids. Then, importance of heat transfer by conduction. How can we use this form of energy? We can use it by in the process of ironing our clothes using hot bodies like flat irons or iron boxes, cooking food, boiling water in kettles or other saucepans, welding or smelting metallic objects, roasting meat using an iron rod, among others. A diagram here illustrates or shows the transfer of heat in gases, which is convection. You can see how heat is moving up from the source to these hands and also to this iron rod. And then also in liquids, a diagram shows how heat is transferred by convection from the heat source to other parts. Importances of convection in our daily life: helps smoke to move out of the kitchen through the chimney. Convection currents helps in free circulation of fresh air in our homes or houses. Convection currents helps in formation of breezes, taking of bad smell through the vent pipes of a ventilated pit latrine. Importance of each of the following on a house: ventilators let out warm air, windows let in fresh air, whereas doors let in fresh air also, just like the windows. Let us look at what we call the sea and land breeze. A sea breeze is when cool, gentle current from the sea moves to the land to replace the warm, risen air, and it occurs during daytime. Whereas a land breeze is when cool, gentle current from the land moves to the sea to replace the warm, risen air, and it occurs at night. Radiation is the process by which heat passes through a vacuum. Radiation is used while roasting meat, fish, or chicken in an oven, warming our bodies using warmers or heaters, dries harvested crops, and wet clothes on wires. Reflectors and absorbers of heat. Reflectors are shiny surfaces that reflect heat and light, whereas absorbers are dull black surfaces that absorb heat and light. Examples of reflectors include mirrors, glasses, whereas absorbers include black clothes and black surfaces. We have a question here: why are most houses or vehicles or most equipments in tropical countries like Uganda painted white? Remember, tropical regions are regions with high sun. Okay, tropical regions are regions that receive a good amount of sunshine throughout the year. Uganda lies in the tropical region, and they're asking us here, why are most houses and vehicles and fridges in most tropical countries like Uganda painted white? Remember, we said white and shiny surfaces reflect heat, therefore to reflect heat. Conductors and insulators of heat. Good conductors are materials which allow heat to pass through them easily, whereas bad conductors are materials which do not allow heat to pass through them. Good conductors include iron, mercury, aluminium, brass, zinc, copper, silver, lead, and etc. Insulators of heat include distilled water, rubber, plastic, paper, cotton wool, clothes, pouches, among others. Here is an experiment how we can determine or show that water is a poor conductor of heat. We see water in a test tube, and then we see a copper wire in the same test tube placed an ice cube placed beneath the copper wire. When the water is heated from the top of the test tube, this water here appears to be evaporating, whereas the ice cube down here remains intact. It does not melt, implying that water is a bad or poor conductor of heat. You can pause the video and go through the observation clearly. Then insulators. Paper is used to make cards. Cloth keeps us warm, and cork prevents heat loss in vacuum flask. Why are handles of iron boxes, frying pans, flat irons made of wood? It is simply to prevent the user from getting burnt, since these materials do not allow heat to pass through them easily. Let us look at a thermal. Sorry, there was a mistake here in writing or creating the slide. It is not a thermometer flask, it's a thermal flask or a vacuum flask. A vacuum flask keeps hot things hot and cold things cold. This is how it looks like. A simple illustration of a vacuum flask and its parts. Then the importance of some of the parts of the vacuum flask. It has the cork, which prevents heat loss or gain by conduction. It has silvered surfaces, which prevents heat loss or gain by radiation, and it does this by reflecting heat. Vacuum, which prevents heat loss or gain by both conduction and convection. It has the felt or cork base, which absorbs shocks to prevent the glass from breaking. Felt are also poor conductors of heat, therefore they do not allow heat to pass through them easily. It has the vacuum seal, which prevents matter from entering the vacuum flask. Thank you for watching, and please kindly subscribe to this channel so that you may get updated when more content is uploaded, and this also helps us to boost the channel. Thank you for watching.